right now the laser is kind of vertical here, and we have the fluid going from this direction to this direction. So the camera here is captured on the side view. It's okay, and this is what we see. Right here I have.
You can also show me the raw images.
What is that?
So always my question is, if the students are, focusing well or not.
Yeah. So,
So is there like very easy way
I don't remember
to?
which version of the software you have, but we have some focusing assist as well, especially if you put in the calibration target first. So usually if you can first visually or physically align where the laser sheet is with the face of the calibration target,
Right.
then you can perfectly focus on that one, and then the particles should be very well in focus. But it's kind of
That's
usually a visual thing that you can try. So these look pretty in focus, but
Okay.
sometimes when you are actually before taking the images, while you can do on a preview. So with the preview, it just shows you, and then you can play around a little bit with the focusing ring to try to see if you can make it sharp as possible. And usually the trick to it is that you go a little beyond to get it a little bit blurry on one side, then on the other side, then try to find the where in between would be the sharpest, because sometimes visually you can't say where it's the sharpest, but when you see the two edges of when it's becoming blurry, then in the middle would be the sharpest position.
Right.
And also, I mean, in this case, you have good particle sizes, but there's another thing that you don't want the particles to be too small or less than 1 pixel. So you don't want each particle to be just one highlighted pixel, and then the rest would be completely black, because we ideally want to have sub-pixel accuracy, and in order to have the sub-pixel accuracy, your particle needs to be about 2 to 3 pixels at least in the illuminated area. So that's also something that sometimes people have a little bit of issue on that one, but in your case I can see that the particles are large enough.
And then another question I have is this density of particle looks appropriate, or like are they using it too small or too many? Or?
What it kind of depends on
Flow
two
rate?
things. So yeah, one of them is your flow rate. I believe you're using double frame mode, right?
Yeah.
Okay, so do you know what window size you're using, interrogation window? Are you using the 32 pixels as the smallest one, or?
I think this is 16. The resolution
16?
16 might be a little too small, but let's see. So we can actually put a grid in there. You said 64 or 16?
60 or 16?
So this might be too small, because ideally you want to have about I would say at least 5 to 10 particles in each of your images. So there's a fine tuning going on. Sometimes you can't change the number of particles you have or the size of the particles. So you may need to increase your interrogation area size. So I would say with this one, we probably can go to maybe start with the 64. So this is actually the 64 is much better, because what the fundamentals behind it is that in each of these windows you want to have a unique pattern to be able to find it where it went in the second frame. So the more particles you have, the more unique pattern you have there to be able to follow it. If it's, for example, this one, it could be relatively hard to get a very good correlation map with where it's going next. So ideally you want to have, I would say, 5 to 10 particles in each of these. So sometimes you can't get away with that, but depending on, you need to optimize a few different parameters to be able to do that. So in this case, I believe you can benefit from increasing your particle density a little bit, not too much, but a little bit. And there's also, let me also check your software version. They're using the 7.6. So do you remember when you purchased this one? And
It was like 2021 or
Oh, I see.
yeah.
So yeah, we do. We have gone a few versions of the software further now. I think we are on 8.4 now.
That's right.
So we have added in some features. I don't know if this one also has that, but I can go and have a look. So we have a particle density help as well. So if you during the measurement, you can do a preview and it finds a small window and says how many particles you have in there and kind of suggests what if you increase it or decrease it a little bit. So that kind of helps you out to how to optimize your particle density. But with this one, I believe you can get away with using a little bit more. And I would suggest using maybe 64 or 32 would be pushing it. If you are getting a lot more particles, you can push it down to 32. But 16, the problem would be if you don't have a good enough number of particles in there to be able to follow that, it's not going to give you very accurate results because the more unique those features are in each of these, you get better match in the next frame.
Okay.
So what I mean by 16 is if I do
The processing.
the processing here, and I'm gonna go with the
The adaptive PIV, yeah.
and then I choose 16 step website here. Yeah, which step side?
Oh.
Here. And it's look
Oh,
like
so
a
that's
resolution,
the
yeah.
16 is the step size. So the
Yeah.
so you're actually using 128. So that's better.
But is it too big?
It's not too big. It depends on. I believe it should be good enough. So 64 and 128 both.
Right.
So 128 might be a good number for this particle density
Okay.
because now you have more particles in there.
Right.
And you may want to start with the larger one in the maximum one because sometimes the way you, so this can be done in a slightly iterative way. So first you look from bigger picture to get the large flow structures and then you can use the information from that one when you're going in to find. So basically you have a first guess of where the smaller one is going so you spend less time moving around to find where it actually went from the first image to the second image. So the fundamental for finding the correlation is like this. So you have this window with this unique feature in the first frame, and then you go into the second frame, you start to move this window slightly around that area to see where is the best match for the same feature now happening in the second feature. And then the vector that you get from the first position to the second position would be your velocity vector or your displacement vector, which when we divide by the delta t we have between the two, you get the velocity vector.
So what do you mean by the first feature? Because right now here, how can you track that here, right here? Because you see, you said we start from the maximum.
Have a PowerPoint that I can show you something quickly, might help. So that's kind of on the fundamentals of some of the. Usually, it helps if you know exactly what the software or what the processing is doing to try to optimize your experiment to get the best results, or maybe even thinking about designing the experiment beforehand to try to see how to get the best results based on your setup. But the idea is that, as I mentioned, so if I go, so can you see these grids? So we usually start with each of these small windows. So we have the particle pattern is in there. And for each one of those, now in the second frame, we are looking around that area to see that unique feature where it went. Did it move like 3 pixels to right and 2 pixels up? Then that would be your displacement, when it's the best match to the same feature. So that's one of the reasons. And then the way usually it works is that now we have these, we don't go the side by side. So we actually go with an overlap of about 50%. So if the first one is this one, then the next one would be something here. So that we have a smooth transition and we get more vectors for your measurement.
Okay.
And another thing that now becomes important is that based on the processing features, you don't want from your first image to second image to move more than, ideally I would say, 1/4 to 1/3 of each of these windows, to not move more than that between your first and second frame. So here I believe the toggle would be T, yeah. So you can see in this one, I don't actually Is this the way it's moving?
Looks like that, yeah.
But you can see that this is one of the things that you want to look for to see if you can easily spot features moving. So in this one, it's a little hard. So let me go a little further back to see. So I don't know if it's a... So this is in the image masking we have. So which one is this that's open? Is this the one we were looking at, for example?
Like this one.
So we don't start with the image masking. Let's first start
Yeah.
with the actual input. So it would be this one. Yeah, so with this one now you can actually see the movement, right?
Mm-hmm.
So your second image is a little less, or has less light in it. Yeah, your second image, for some reason, it's actually lower in intensity. So that's one of the things that would help you get better results, is that both of the images have about the same intensity. So you may be able to adjust the two shots from the lasers to so that you are getting the same kind of intensity from them, so that the closer they are, or the less optical artifacts you have between the two images, the better match you can get. And then some other things that will help you with these measurements is that we can do a little bit of image pre-processing. So one of the main ones is that, as I mentioned, we want to look at this pattern and how it's moving to get the velocity. Now imagine, in addition to these particle patterns, if you have a pattern in the background, for example, you have some feature in the image. So then in a small window, for example, in this, can you see this kind of strip of dark? So when we are looking at the entire intensity. So that one is not moving, but the particles are moving. So we're not going to get a very good match when we are moving this around. So in order to avoid that, it's a very good idea to first remove the features that are not flow related. The way we do that is usually we can subtract the background features. There are a few different ways we can do this. By do this, I mean how to calculate what is that background. So sometimes people actually just get the minimum. So for example, you have 500 images. So we can get the minimum value of the of each pixel over that 500 images. So that would be the blackest, means that's when sorry, no particle is in there. So that would be your background. That's usually good if you have a good intensity. But sometimes if you are low intensity, then you can see the noise of the camera. For example, some of these black and gray dots that you see, some of those is that because you have such a low intensity that you're getting close to the noise level of the camera, which is usually a few intensity counts up and down. So you want to avoid that. So in that case, if you actually just get the minimum of about 500, you would get probably a zero value, which is not technically a feature you're getting. So a better way for that would be to get an average of entire 500 images. So what are the chances that there's a lot of particles on that specific pixel over the 500 images? So usually you would get something close to the background, but slightly higher, because it's not, there are a few instances that there are pixels in there. So you lose a little bit of intensity, but you get the features better in case you're on the lower level of intensity for your image. And sometimes when people have transient phenomena happening, which means that their background changes, you can actually do it as a moving average kind of. So for each image, you look at like 5 images below and 5 images after, and then try to subtract the background based on those 10 images, let's say. For example, imagine you have a combustion type of flow, which you have a plume that's also moving. So if you have a feature that's moving with the flow, or not with the flow, but moving, creating patterns in there, you want to avoid that. But if it's not a steady state pattern that you can just remove from all the images, then you might actually looking at smaller features or a smaller number of images and move it around.
I think I kind of guess what you mean, but so here we have the heat bloom. That's what you say is we have the transient problems. Here we try to visualize the heat bloom inside that channel also. And what you see, the vertical line here is kind of the noise that we get a lot. But this is not come from the background, it's come from the tiny part, the tiny bubble that we get.
Air bubbles, yeah,
Yeah,
on
it-
the
it
water
It
surface.
could be air bubbles. Sometimes it could also be. May I ask what is the property of that top window? Is that
It's
plexiglass?
Plexiglass, right?
Yeah, yeah.
So that's
Acrylic,
another.
yeah.
That, actually, that could be from the acrylic itself. So sometimes
Yeah.
some of the acrylic they don't have a very uniform intense
Surface,
density on the surface. So some portions actually absorb the laser more. Some portions pass the laser more. So you get some of these features. If you want to improve it on the hardware level, it would be if you want to
Yes.
move to still with the plexiglass. Sometimes you can get some that are called optically clear acrylic or plexiglass. You can even find them on MacMaster. So those would cause less of an issue like this. And the next better one would be optically clear glass, and then very, very expensive would be quartz windows. But that's something that on the hardware level you can try
Right.
to avoid this issue. The bubbles could also create this, which this could be a combination of both bubbles and the surface. For the bubbles, depending on how it might actually affect your measurement, you might think about actually doing some sort of pre-treatment on the bottom surface, so make it a little hydrophobic, so that you don't get the particles staying there or the droplets staying there for a long time, or actually just falling down, so that they won't block your laser light. But all of that means that if you have such features, then it might be a good idea to actually remove those before doing the PIV processing, because then these ones are also showing up or affecting what you get from your PIV results, which is not technically your flow in that case. So it's a heat profile, which is not the velocity profile. So that's a very good way to do your processing, and I can show you how to do that for one of these. Sorry. So starting with one of the raw images, which one? So let's go with this one. So this is, and when I put T, it actually toggles between frame A and frame 1 and frame 2.
Okay. Yep.
So one thing we can do on this is we go to analyze, and then so in the image processing we can do a first image mean or image there should be an image arithmetic somewhere. Yeah, so either one of these could work. So if you go inside this one, you said no, this is not calculating that, sorry, this is the second step. So the first step would be actually the image mean. So in this one, it says it can take the average of all of these 100 images that you have. And if I do that, so this is the background. So it has calculated that mean average that you have. So I believe it should have done it for both the first and second frame. So now in the second one, we select both of these together. Then we go analyze again and image processing still, and we want to do image arithmetics. So basically, if you want to do any mathematical processing on the image. So if I do this, I say the operand that I want to use would be what I'm going to do is parent minus operand. So it means the actual image subtracted by the background, which is the child of the first one. So now if I do this, I can show you how it differs from the raw images. You can see that you have less features now on the bottom side.
I see.
So the way that I've done it right now is if you have a static background.
Right.
If you have a more moving transitional, then you have to do a time average or moving time average way to do it. But this is like what it looked like before, and this is what it looks like right now. So you can see if you move to the particles, it's cleaner. There are less features and noise around.
I see.
It's a little bit worse on your second image, as I mentioned, because you have such a low intensity. So you might want to try to see if you may be able to increase the laser intensity if you are doing on a lower level, or if you maybe if you can still open your aperture further, but I think you're all the way open now. So another thing is that you can also increase your intensity if you play with the laser sheet thickness. If you actually make it as thin as possible, means you get more image, more intensity in this where you're looking at those particles. And I think another one, so can I ask, what are you using for the particles? Is that just like mist for your particles?
Mist?
It's actually,
Yeah, it's a Dantec PIV particle.
Yeah.
Oh, so it's actually,
it's actual.
Oh, so it's a water flow. So one of the things you can get away, if you see that this is not giving you enough light or you want to improve your light, if we use like 50 micron particle sizes, so basically what we're looking at here is the scattered light back from those particles.
Right.
And the intensity of a scattered light has a quadratic equation with the size. So
Right.
if you actually double the size, then you sometimes, I forget, either 4 times or 8 times more light it gets back. So that's one of the things sometimes when people can't increase the light intensity they have with the from the laser and camera, then the other thing is that if you increase the size of the particles, you get a lot more light reflected back to the camera. So that's one thing you can try as well. But I would say the first ones would be try to play with the laser sheet, maybe decrease your, so I don't remember how many angular modules you have.
What do you mean module?
With these guys, we usually have a, what's basically making it go divergent. So we have 3 different levels of divergence.
Right.
And as you can imagine, the more you make it diverge, the less intensity you're distributing over a larger
Right.
area. So sometimes focusing it a little bit to a smaller area will give you more light. If that's something, but there's always a trade-off. Then you're sacrificing some of the position you want. But if you have some light to spare, then it might be a good idea to go smaller. If you see that your light is big, that it's actually hitting the sides,
Right.
then it means you can get away with actually bring it a little lower so that it's now a smaller area.
Right.
You're not wasting any of the
Sure.
laser intensity on the sides or where you don't need it.
Right. But I think you guys don't know how to adjust the angle, right? The divergence angle.
I think the setting Nam is using right now is only 10% of the actual laser power.
Oh,
I mean,
so-
but
so
what we're talking about the divergence angle.
Right,
So
but
the divergence one
Yeah.
is actually, it's a hardware lens that you
Yeah.
have in there. So I
It's
have
already
to double
fixed, right?
check what you have in there. You may have only one available, but sometimes we have extra ones you can buy to just
Right.
replace or actually mount on top of each other. Sometimes if you want to
Okay.
get a very large divergence.
Right.
But yeah, if you are using 10% of laser intensity, just push that
Increase,
up.
yeah.
And also a lot of these lasers, other thing is that they're usually not very stable on very low
right.
power levels. So you wanna, I would say more than 20-30% use that
20.
one. So you don't wanna go very low, because as you can imagine, if something is designed to do 1 watt, if you're using it in 1 milliwatt or 2 milliwatt, that's not very stable because it's not designed to be that accurate on that intensity level.
Okay.
But yeah, I believe some of these you can easily improve with just increasing a little bit more particles, I would say. But that could also be that the reason we are not seeing many particles could be also because your laser light is relatively low. So first of all, just dial up the laser power. You might actually just even see more particles, also see the smaller ones. But if you still see that you don't have too many particles, you can add a little bit more particles. And I'm not sure if what is your procedure for adding these particles to water, but usually these are polystyrene plastic, so they sometimes get surface tension, and also because of static electricity, they get to bunch up together. So the best way to actually add them is at first have a beaker, add these particles, add like 1 drop of dish soap, or if you have isopropyl alcohol, a little bit of isopropyl alcohol. So that breaks down the surface tension a little bit, and then add water to that relatively or slowly and mix, and then add that one slowly to your main mixture until you see you have enough particles, and then that's where you can stop. But it's usually better to not directly add them to where you want to do measurements, to create the mixture somewhere else, make sure you use some surfactant, as I mentioned, like isopropyl alcohol or sometimes even dish soap. But with the dish soap, you might need to be careful not to put too much to get bubbles. So you want to get a tiny bit just to break out that surface tension. That way your particles would stick less to the walls and to each other, and they would actually move with the flow. So those are some of those things. And then, as I mentioned, with the delta T, sometimes you can get away with, depending on what size of that interrogation window you're using. So let me show you here what this was for the, if I show the grid again. So now let's zoom in a little bit more. So you can see these two are moving this way. So this is a good for this 64. So you are seeing that your main motion is about 1/4 or 1/3 of the interrogation window size. So sometimes you don't want to also go too small of a displacement, because then you can imagine, so usually the pixel resolution for finding the motion is close to, I would say, 0.1 pixel. So you can imagine if your average motion is 10 pixels, then your accuracy is better than 1%. But if it's actually moving only 1 pixel, then 0.1 out of 1 is actually almost 10% uncertainty.
Yeah, so I have a question because the way the particle move, the distance the particle move depends on the time between poles that we choose.
Yes, so that's like I actually need to go the other way. So you start with a delta T, then you actually have a look at how much they're moving in your image, and then try to make it smaller or bigger, so that you are getting large enough displacement but not too large.
So your suggestion is like the particle should move like around 1/2 or 1/3 in the
one half is too large, so 1/4 or 1/3 of the size that you want to use. So
okay.
in case you're using 128, let's go 1/4 of that would be up to 32 pixels should be fine.
32 pixels, okay.
That's 1/4, right?
Yeah.
So up to 32 pixels, but that is still slightly large, because depending on the time scale of your flow, then you might be actually missing the smaller. So as I mentioned, it's always a trade-off what you want to do. So ideally you want to go to a smaller window. So if you increase your particle and light, you can use 64 pixel interrogation window, which in that case you can have I would say like a 16 pixel displacement. So usually people say for a 32 pixel, which is usually the smallest one people go to for a regular PIV, they recommend something closer to like less than 10 pixel would be ideal displacement as a rule of thumb.
So let's say for this one right now, we have this particle, and if you T here,
And you could just do, you can see, go back and forth.
yeah, let's say this one, and this one will move to this pixel.
Yeah.
And you said it's like 16 pixel. I don't understand, because here it's just 1 pixel. It's just moving 1 pixel.
This is not one pixel. So the pixel, if we actually zoom in, I can show you.
I think you just scroll it.
Yeah, so I don't know which particle is this. So the pixel location sometimes actually shows here. Yeah. So our position here is actually 110, but in the previous one, it is, so I was reading the wrong one. So it is 168.
Okay.
And then in here, it's actually 154. So this is moving 12 pixels now.
I see. Okay.
So 12 out of 64 is still a good number. So you don't wanna have very, very small, but depending on your window size, there is a maximum that you can get up to that one and still get good results.
I see. Okay.
And the first suggestion that would improve it significantly first would be just the laser intensity.
Right.
But then just doing these mean and average background removal would also help a lot with, because some of these like dots, these are noise levels that are on there, and they have nothing to do with your flow. But if there are too many of them and too little number of particles, then those will also affect what your correlation is trying to find.
Yeah.
Because generally on the programming level, this is creating a function to calculate what is the correlation between here and here, and then the peak of that one would be where it says this is where it actually went. So all of these can affect that function that you're getting the output to do your optimization based off of that.
Okay.
So this would be my first.
Oh, okay.
And then again, on the analyze side, you can also do masking a little bit. So for example, you can see that you have some areas that you don't have any particles in, which I would imagine means that you're probably looking at this wall.
Right.
So if you want to save some processing and also not get very wrong data on the edges, you can actually put a mask in this area and say to ignore that area. Do not spend any time processing it, and also you won't get particles trying to move around, or a window that has half particles but half empty space. So that will also not give you a very correct answer.
So here is I think that because before right here we
So you do masking?
I did do masking.
Okay, so
yeah, but here we have the problem right here, because before I do an analyze, if I can input the mask image, but right now this one just disappear. I don't know if
so that's, I think you have to select both of them on the same size. So this is already masked, right? Or it's not masked?
this already masked. This is identify the mask.
Oops, I think I may have accidentally closed this. So do I have a cancel option, or?
I don't think you can get just.
Okay,
I
so
we open it
leave
again. Yeah, that's
all
fine.
items.
I'll
Yep.
open it again.
Sorry.
Okay, I also hide this because we don't have the cancel option. We just
Yeah,
close
I have to. It's actually works better if it comes from you, but there is a suggestion part on there that you can actually say that this is a feature that I think should be there. So if it actually comes from the customer, it goes faster than if it comes from me as one of the technicians.
Yeah, so here we have so I just show you the
So the thing is that each mask needs to be from under its own image. So you can't use this one with that mask. You know what I mean?
Yeah.
So you need to also define a mask for this image and then perform the masking with its own. So for example, I think if you select these two, and you also need to just use this one, then you can probably perform the masking. Where is it? Okay, I have to go here. Why it's not showing me the option? Do I have too many things selected?
I think you can go preset here and yeah.
Oh, that's the pre-process.
Yeah.
Okay. So you should have the image masking here. Right?
It just show
WE.
masking here. Oh, yeah.
Yeah. So in this case, okay, so I always forget. So a lot of times if you actually click on this, it will give you the help, which has all the information of how it's doing based on the mask you have created or defined. So depending on the mask, you can ignore or use outside or inside of it.
Yeah.
So I have to double check what you have used, but I think the area outside of the mask is of interest in your case. So if we do, let's just apply that, does it for one image.
Yeah. Should I think yeah.
So if we go to, so now you can see that it has actually blocked it.
Yeah.
So you need to either do this first, and then you can perform your processing on this, which I think I have to first deselect everything, unselect all. So now if you have, which one is it? This is the one we created, yeah. So now you can perform your processing on this one. Why does it only show the pre-processing here? clicked on something.
This is pre-processing.
This is under the calibrations.
Oh, that's
Yeah.
because on yeah. So that's because it's on the calibration. But for these ones, you also let's check these. So in this one, you have actually applied the masking. So yeah, you're already doing that. So you might just want to play around with where to put it to get the best results, to not get too much noisy vectors on the edges.
Yeah, but I don't know, because I still cannot input the mask right here. Let's say we have this one.
So if
Yeah.
it's already been applied to that masking, when you have this image masking, if you perform the processing on this one, it's already performing based on this image, which already has blacked out this area. So you don't need to do any additional masking. So
Okay.
the reason we had that was that sometimes people can ignore this part. So you only have this image, then you define the mask, and when you select both of them and go to analyze, you can say use this as a mask. So basically you're skipping a middle step to first applying the mask yourself and then processing. You can say use this mask for processing, kind of jumping over one step. That's the difference, how to do it. The end result isn't much different.
Okay. So we don't need to, like, in the analyzer, we don't need to input the mask anymore.
No,
Just to use
if you have already applied it like this, you don't need to do that now.
Okay. Yeah, it's cool. Yeah.
Yep, and so I think these are some of the things that you can use as for improving your results and your images. So one of the main things with the PIV is that it's usually a lot easier to try to get make everything better on the optical size. It takes a lot longer trying to work with an image that's not good than to actually first spend the time to make sure the images have the highest quality you can get and have the least amount of artifacts or errors in the beginning, then try to actually remove them afterwards. That usually takes a lot more effort.
Okay, and I think also another question I have is, can you show the leaf, video? So yeah, this one now. So you said, some static noise can be removed by subtracting the background, right?
Yes.
So I think the vertical lines are kind of static.
Yes,
So
they are.
yeah, would you actually show us how to remove
Yeah,
those
can
vertical
you bring
lines?
that
That would be like
project that you-
fantastic for everybody. Yeah.
They usually image pre-processing is the best way to do this, and
Right.
the but the challenge with image processing is that there's not always just like these 5 steps you need to go through and it works for every project.
Right,
So it's
right.
a little bit of art to play around with your
Right.
images to see what you need to do or not to do to make it best. So sometimes for example, if you have let's step back in your such PIV, but where you have these low level noise that you have these very small dots. So there are some ways to actually use a Gaussian blur to try to
Yeah.
get them out so that they won't affect your larger particles.
Right.
So, but that's not usually the best way. If you already have clean data, then it would actually add noise to your
Right.
measurement. So it's always depending on what you are starting with, that what are the steps you need to take. But usually background removal is helps a lot.
Let's see this one.
Yeah, this one.
Yep. So can we first just go through them a little bit to see?
There are some static noises.
Yeah, most
Usually the
of
vertical. Yeah.
a lot of them are steady, and I think there is also one way. So for the color map, sometimes you can also. So this is the raw image, right? Or is it
Yeah,
after
right.
processing?
After processing.
So this is
The raw
after.
should be here. The raw should be this one. Yeah.
Okay, so let's have a look at this one. Yeah, a lot of them are static. So I guess one of the things we can do, is it alright if I do it on this one?
Yeah, just do it. Yeah.
So let's go analyze, and we want to calculate image. So there should also be another one. Let me try to if I can find that. So image math. So this gives you more. The mean only calculates the mean, but the math or min max give you more options. So let's use min max. So we want just calculate the minimum of them. Let's see if this one how it looks. So depending on the image, sometimes it helps, sometimes it actually makes it worse. But this is something that you are seeing. So some of these, I'm not sure if these might be some of your actual LIF features that we might be removing.
Let's say, is this the raw image or yeah, it's a raw.
This is the raw image.
So if that raw image, we can use this one.
Actually, yeah,
Yeah.
the minimum area would be the higher temperature one, so we would be removing the.
Yeah, so
Yeah.
that's what becomes a little bit. So in this case, since you have features that are also moving around, you can't use a static one because it will also affect that. So
Right, but I think we can ignore some of these features. I think we have like bigger temperature.
okay,
heat
sure,
flow
yeah,
motion,
I
so
can try to
at
apply
least,
this
yeah.
one to see. Okay, let's select this, and
At
then
least we can capture the major flow. So.
yeah. So in image processing, we go here, and we go again parent minus operand, and let's.
Curious.
What's that?
Okay, so I guess now because we have
Nothing?
done that, no, we have to adjust our histogram a little bit. No, seems like
Subtract
we're not. I guess that could be. Let's see what it was in the beginning. So what is the? So it's from 16 to 55. And then what did we get here? So this is, so yeah, this is like actually the main chunk of the image is being removed because of that. So that's, it's a little harder on the LIF side to do this, because for the PIV, what we have is we have the background is completely black,
Right.
the particles are bright, so we are not removing the main features. I have to look to see what is the best procedure
Right.
for LIF, but there are a few image processing
Right.
procedures you can use for this. So let's have a look again. I have selected both.
Yeah, but I think maybe next time we need to use higher quality top surface, or sometimes actually you remove the
Yeah.
top surface, right? We remove the top area.
Yeah, that should also help a lot usually.
Right. But then we don't have the closed channel.
That's right. Yeah.
So I don't know how long you're gonna stay here, but I think it's 1 hour, right? So maybe we can ask him on the horizontal PIV if he has any.
I mean, yeah. Are you available?
Yeah, sure.
Yeah, but yeah, if you can actually show us like quick fix.
Yeah, sure. So for this one right now, I don't know off the
Okay,
top
okay.
of my head
Okay,
which
okay.
one is the best for LIF. I haven't
Alright.
done LIF in a long
Okay.
time.
Okay.
But I can look into that. So let me just make a couple of notes
All
to
right.
what I wanted to check for you.
So much lines.
So much what?
So much lines here.
First one was vector scaling. The other one was.
I think maybe we can go like we can try a expensive acrylic paint, Mastercard or something. Yeah, I think we all use the normal one.
Mhm.
Yeah.
Yeah.
So try just buy one and try. Yeah, I think he's want to explain the horizontal PIV.
Oh,
Yeah.
yeah. So the next one is, maybe we need to change some hardware here.
Okay.
So currently we were only measuring the vertical plane,
Yeah.
right? But we are also interested in horizontal imaging,
Yeah.
Yeah.
and
So
of
do you
course
want to
like
do
Dantec
at the
can.
same time or?
No,
just-
separately. I mean, same time is of course better, of course, but I think it's gonna be like
Yeah, it's
more
gonna be like
expensive.
probably another PIV system, something like that.
So separate is okay.
Yeah, so for that one,
is it-
one of the first things is that you can actually move the laser to the side and rotate it this way so that your laser is shooting this way and the camera looking from the top. So that would be the,
yeah, but without, but I'm actually really concerned that like moving the laser, like in a different position, maybe can damage this component while like
Yeah.
students are doing this thing. So,
so you want to still keep the
Keep the
still
laser,
a
like here?
convection flow, right? So the
Yeah.
gravity matters. You can't
Right.
just flip the
right. So can you show the page 3? Yeah. So like we are trying to put a lens that actually expands. So right now it's a very thin laser plane, but the concave lens can expand the laser sheet a little
Yeah.
bit, and then meniscus lens actually they collimate the light. So actually there's a beam splitter here. So this is a beam splitter.
This is beam splitter.
So what happens is like a little bit thickened laser sheet. It's gonna be like maybe 3 to 4 centimeter of the laser expanded light will go into the channel, and then beam splitter will reflect the light to the meniscus lens, and it's gonna collimate the light.
Yeah.
But my question is, like, if Dantec also has some simple solution.
So this could work, but then the thing is that the more optical
Right.
elements you add to the
Right.
system, there are other distortions or
That's right,
artifacts
yeah.
that can come in. So still, the easiest way would be to actually try to modify your setup to be able to do that. And I would say, without moving the laser, another thing would be if you could have another like test section, maybe another place for mounting the test section either on this side or this side. Then for example, if it's on this side, you can just rotate this portion this way, and then your camera can look from either the bottom or top. So that would be the
Yeah.
most straightforward
Right.
solution. It wouldn't cost you money,
Right.
and also it wouldn't affect the quality of the images, because
Right.
as you can imagine, everything that comes like this, it's adding a little bit of distortion or
Right.
gets a little bit of light, especially if
Yeah.
you are doing LIF
Right.
measurements, or even with the PIV. All of these can affect the quality. So it is doable with additional things
Right.
if you don't want to move your setup.
Right.
But I would recommend highly that actually just adjusting the setup
Right.
for that would give you the highest quality results.
Let me jump in a little bit.
Sure.
Yeah, so because we did try to like kind of flip the channel, like just flip the channel 90 degree, and
Yeah.
then
But we are
Yeah.
visualizing the channel with the internal structure, so it's gonna
Yeah.
make shadow of
and
the laser.
here we don't see the light because light coming on this way, and here this
Shadow.
filter block the light.
Yeah.
Yeah.
So for this, that way, usually there is no such a good way around it. So sometimes people, if they don't have out of plane motion, or usually with micro channels, you can get away with using with something like a backlight PIV. So it can be either laser or sometimes just LED looking through the camera. But the problem with that for an actual PIV measurement would be now you're illuminating all this depth. So you're looking at all of those particles, and they're actually, because of the lens construction that we have, the scaling factor is different when you're on this side of it or this side of it. It could be very minuscule difference, but depending on how close the lens is and the actual lens, it might actually be a relatively significant difference with this scale factor. So that means that you are adding some artifacts to your measurements, and you're not measuring in a single plane anymore. It's actually kind of getting all the volume information. So for that one, the best way to do that would be either moving to a stereo PIV or a kind of like a ideally
Yeah, stereo.
volumetric PIV,
Right,
which
but
still
then
can be done. So some of these things, your channels are small.
Right.
We have LEDs that you can for the volumetric illumination, but the cost still would
Yeah.
be the camera and the processing
Right.
for the volumetric. So usually that's the best way. Another way I have seen people use it is that they use a beam splitter on the laser to now try to shoot the laser from the two sides, so you get the least amount of basically blockage going in. But for some of these, I mean, you have a lot of them, but I have done measurements like this with a single cylinder or airfoil, and sometimes you flip it around to get the two sides and then you stitch them together. And just another comment that might make life a lot easier in this case would be, for such a case that you are measuring close to the surfaces, using fluorescent particles and a filter on the camera would also help a lot, because the problem is with the regular PIV, you are looking at the same green light from the particle as the one that is getting reflected from the surfaces. So the more matte you can make the surface, it's better, but sometimes still you may end up with a glow around it, which sometimes you can filter out. If you can be conservative and go a little larger with your masking, but if you're actually very interested in what's going on close to the surface, one thing people use is people use fluorescent particles, which means that the particle is coated with rhodamine G or rhodamine B, which absorbs this green laser and emits orange light. And then you put a filter on your camera to only receive the orange light. And that way you don't see any reflection or glow from the surfaces anymore. So you can get closer to the surface if that's one of the things you are looking into. But for this type of shadow and light blockage, that's usually on the optical level to actually go there. Basically, it would be finding the best angle to try to have the least amount, or maybe have two approach angles to kind of cover each other.
Right.
Sometimes people use two lasers, but the two lasers just sometimes adds a little bit of complexity because you need to synchronize them to perfection, and sometimes they have their internal, so the synchronizer can do that, but you have to play around because some of these have a slightly different internal delays from when they receive the trigger to when they actually shoot the laser that could be slightly off, which may or may not be significant for you. So for some people, if it's a few nanoseconds off each other, it doesn't matter. But so your idea was that you wanted to actually just make a volume out of your laser sheet, basically. So that could work, but then the problem would be the camera is also looking for the entire volume.
But there's still, but the camera also should focus a certain position, right?
Yes, but the thing is that it still we have to look into your lens, how well it does.
Right.
Usually the depth of field is different. Some of the lenses have a depth of field of about a few millimeters. Sometimes they can be up to 1 centimeter already. And also that depth of field is not like a really very huge cutoff. So you would still see blobs. So the thing that happens if you have a relatively large particle peeing here, it actually blocks off behind it. And then also you can see blobs of it which are moving at different rates and with different scaling ratios. So you don't get very accurate PIV results. So that would be the main issue in there. Because you can imagine, instead of just particles moving here, you also have a group of particles moving here and another here. So each one of them has a slightly different scale factor. And even though they would not be sharp, even the blurriness is affecting what you're seeing because you're only looking at a pattern. That would be the main issue.
Okay.
But depending on your particles, like a shadow sizing could also work, but that usually would work if you have a very thin flow, so you can make sure that everything is 2D.
Right.
So, and also your depth of focus is enough so that you're not getting too much different scale factor. So that's usually one of the limitations of doing a backlit PIV or shadowgraphy, basically. So that would be the correct term for when it's backlighting. You are looking at the shadows of the particles.
Right. So actually, under certain flow condition, the flow is mostly 2D. There is not much vertical flow motion. So
the flow is 2D, which is good, but still your depth is kind of a little hard. But if you could push it to more thinner channel, you might get away with something like that.
Right.
But yeah, that's usually one of the main challenges with doing PIV with something that's has a lot of these things.
Right. Okay. Yeah, actually, that's a lot of help. So much help. Thanks a lot.
Yeah, no problem. This looks an interesting
Yeah.
flow. But yeah, let me give you my